Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes percentiles and how to find them. Let's get started. Percentiles are simply measures of location. There are 99 different percentiles in a data set, and they're denoted with a capital letter P and a numerical subscript that indicates the percentile we're talking about. So P sub 1 or P1 is the first percentile, P2 is the second percentile, and so forth all the way up to P99, which is the 99th percentile. In essence, when you see a percentile, what you're looking at is the area under the distribution curve to the left of the x value that corresponds with that percentile. Let's say we have here a distribution of our data values, and imagine this to be something like a histogram where we've connected the tops of all the columns for our data set and to make it this normalized bell-shaped curve. And let's say that we want to look at this x value right here. Well, the percentile that corresponds with that x value is the percentage of the area under the curve that is below or to the left of the x value. So if this x value represents, say, the 99th percentile, or P89, then the area under the curve to the left of that x value, which you see shaded in red, will be 89% of the total area under the curve. And because the percentile represents a percentage of the area under the curve, we can also represent it as the percentage of data values that are less than our x value, which is the number of data values less than our x value divided by the total number of data values and then multiplied by 100 to convert from decimal form to percent form. So we have two different ways of looking at the same thing, but either way, that's percentile. Let's return to our chocolate chip cookie example to illustrate because, hey, I love chocolate chip cookies. That's why I keep coming back to them. But this time, we have chocolate chip counts for 40 chocolate chip cookies and not just 5. And we're asked to find the percentile for a cookie with 23 chips. Well, the first thing you want to do is make sure your data set is sorted from lowest to highest, because this makes it easier to make your counts. Fortunately for us, this data set is already sorted from lowest to highest. Second, you want to count the number of data values that are less than 23. That's the number we're interested in, 23 chips. So we start by locating the first 23 in the sorted data set. If we look at our sorted data set here, we see the first 23 is located right here. Then we count how many data values we have that are less than 23. So we start here with the next lowest one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 cookies that have less than 23 chips. Now we calculate the percentile of 23 by taking that 10 and dividing it by the total number of cookies in our data set, which is 40, and then multiplying by 100, which gives us 25. This means that a cookie with 23 chips is in the 25th percentile. We can use StatCrunch to calculate percentiles, although we don't calculate them directly like we do the mean or the standard deviation. But StatCrunch does make it easy to sort data sets and then get our counts. Let me illustrate with the chocolate chip cookie example we've been using the past few mini lectures. Once you place your data into StatCrunch, you want to make sure the data is already sorted. In this case, the data is sorted, so we're starting from the lowest value and moving to the highest value in our data set. That's what we want. Now, once the data is sorted, we want cookies with fewer than 23 chips, because we're asked to find what percentile a cookie with 23 chips is in. So we look for the first occurrence of 23, which is right here. Then we're going to look at the row number directly above the row with that number. So the first 23 is in row 11. That means we're going to go one row above that, and that's going to be 10. Next, we look down at the bottom to get the total number, and that's here. That's going to be 40. And now we've got what we need to calculate our percentile. You see where these numbers are coming from. We calculate it just like we did before. Take the 10, divide by 40, multiply by 100, and we see that they're in the 25th percentile. So in this way, StatCrunch can make the process of finding the percentiles a little bit easier, though it doesn't calculate it for us directly. What do we do if our data isn't already sorted? Well, let's use our POTUS file as an example to answer that question. The heights of U.S. presidents is not sorted in that file. So if, for example, we want to know what percentile a height of 171 centimeters is in, we'll need to sort that data first. We do this by going to Data and then Sort. And in the Options window that appears, we select the column we want to sort, and then we indicate in what direction we want to sort. The default is for ascending, which sorts from lowest to highest. This is what we want. So we're going to leave that as is. Finally, we want to click the box down at the bottom of the Options window to open the results in a new table. If you don't check that box, then StatCrunch will sort the data right there with everything else in your table without also sorting those other columns so that the individual rows stay together. It gets really messy. It's better to just leave the original data set the way you found it. So we're going to put the sorted column in a new table so we don't have to worry about anything getting messed up. And once we have all that, we click Compute, and out comes the data sorted in a brand new table. Now we can just grab our numbers like before. Our number of interest here is 171, so we find the first instance of 171 in the sorted data. And that's going to be right here. Then we grab the row number directly above it. That's a 5. Then we go down to the bottom to see the total number of values in the data set, which is 38. Now we're ready to calculate. We take that total number of data values below the value of interest, which is 5, divided by the total number of data values in the set, which is 38, and then multiply by 100 to convert from decimal to percent form. That gives 13.2%. Therefore, a president with a height of 171 centimeters is going to be in the 13th percentile. Notice that when we get a decimal value out, we round to the nearest whole number. 13.2 rounds down, and that's where we get the 13th percentile. It's not like they couldn't code this functionality in the StatCrunch, but for whatever reason, they took the same route as they did with the mid-range and didn't code it in. It'd be nice if they did. Of course, it would also be nice if someone would just leave $1 million in a box for me to find, but I'm not holding my breath for that either. Feel free to pause the video here, grab the POTUS file in StatCrunch, and see if you can do this yourself. If you get lost along the way, come back and use this screen for a reference. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.